Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about a very interesting math topic from the SAT and ACT. It's interesting because while the test makers may classify it as being advanced, when you think about it, it's something that people generally learn about as early as kindergarten or even before. I'll give you an example. If I said red, blue, green, red, blue, green, red, blue, green, then I asked you, what comes after green? Well, you'd probably say red because that's how the pattern goes, right? And yep, that's the topic for today. We're talking about patterns. Let's take a look. Okay, we're talking about patterns. Now, I struggled a bit with defining what a pattern was here without using the word pattern in it because we all just know what a pattern is, right? The human brain is extremely hardwired to look for patterns, to the extent that our minds actually force us to see patterns where there clearly aren't any in reality. And for example of this, you can just point to things like seeing faces in the moon and on Mars, or seeing shapes or animals in the clouds, or just the existence of all those ridiculous conspiracy theories out there you see. There's not actually any pattern there, but our brain has decided to trick us into seeing one. So for the purposes here, though, I've defined a pattern as a series of repeating values or letters or items or things, really. Really just any sequence that repeats regularly. So when might this be useful? Well, let's take a look at a topic that we covered briefly in our imaginary numbers video. So in that video, I asked what I to the power of 129 is. So you might think to yourself, wow, that is a very large exponent. And I suppose it is, but when we start to apply patterns, maybe it's not that bad. So you may think, how am I going to figure that out? So as I demonstrated, I to an exponent follows a regular pattern. We have I to the first, which is just I, because I need to do the first power itself. I to the second is -1. I to the third is -I. And then I to the fourth is 1. So there are 4 terms in that pattern because after that it's just I -1, -I1 again, and it goes on like that forever. And so how do we get to I to the power of 129? Well, I to the fourth is 1, and then you would go I -1, -I1, so I to the 8th would also be 1. And then that would mean that I to the 12th was 1, and going on and on and on. Every multiple of 4 as an exponent for I is going to be 1. So if we think about a slightly higher number, like I to the 18th, it's kind of clear there that that's just I to the 16th, that's our neighboring multiple of 4, and then times I. So, 2 more i's put in there. And the nice thing is we can just go ahead and call I to the 16th 1, and it will just drop out. And then we have I times I left over, and I times I is -1. And we can do the same thing with I to the 129, but we don't really want to have to count that high. So instead, what we're going to do is a little bit of division. And with this division, we're going to rewind the clock way back. So I don't know exactly when this is covered these days in school because I'm old and things have changed. But when I was in school, this was something we covered in 4th, 5th, 6th grade, and it was remainder math. So if you don't remember, what remainder math is basically just lazy division. So in regular diligent division, we go all the way to decimals. So if you have something like 7 divided by 5, you would say we have our 1 there, -5, and we have 2 left over. We're going to go put a decimal in there and bring down the 2, and that's just going to be 4 because 5 times 4 is 20, and we have nothing left over. So you can do it that way. Another way to look at it is it's just 7 divided by 5 is 1 and 2/5, and a fifth is 0.2, so that's the same thing as 1.4. But with remainder math, we're very lazy. We would just say, all right, well, we're going to stop when we get to a unit. So 7 divided by 5 is 1, and then we take away 5, and we're no longer in whole numbers, so we're just going to say, I don't know, there's 2 left over because we don't know what to do now that we're to this point. And this is great for pattern math because the remainder is really the only thing we're worried about because as we can see with I to the 16, this just goes away. Our pattern repetition, we just don't care about that. So what we can go ahead and do is a little bit of remainder math for I to the 129. So we're going to take 129, which is the iteration that we're looking for, and we're going to divide it by the numbers in the pattern. And so there's 3, 12, we're going to have nothing left over, bring down the 9, and then we're going to have 2, and then we're going to have 9 minus 8, and that's going to leave us with 1. So we're 32, remainder 1. And what that means is that we have 32 times going through the pattern, and then it's the first term in the pattern. So in this case, the first term in our pattern is I. So I to the 129, that's just I. That's the same thing. And we can all agree that that's a much easier number to look at. So before we look at practice problems, I'll say that what we need to do here is divide by 4 because there's 4 terms in the pattern. If there had been 5 terms in the pattern, we'd be dividing by 5. But regardless, generally what we do to solve a pattern question is we take the number of terms in the entire sequence and divide by the number of terms in the pattern and look for the remainder. So if the remainder is 0, that means it ends on the final value in the sequence. So any multiple of 4 for I is always going to be 1. Okay, hopefully that makes sense. Let's take a look at some practice problems now. Okay, take a look at these and see what you can do. All right, let's take a look. Okay, this first one here is based off a question I saw on an ACT a couple of years ago, and I just love this question. It's exquisite because you see 7 to the power of 236, and it's a calculator test on the ACT, so you punch it in and you see what you get, and your calculator says, no, thank you, that number is bigger than the universe or something. That's an outrageously large number. But then you look and you realize you don't really need to know what the whole number is. You just need the units digit of this number. So the very last number, and that's another reason you can't do it with your calculator, because after this gets to be like a 15-digit number, you're just going to get decimals and exponent form. You're never going to be able to see what that last digit is. So it has to be something else going on. And what's going on is we're worried about the units. So everything like to the left of the units digit we can ignore. So 7 to the first is easy because the units digit is just 7. And then 7 squared, there's a 4, we don't care about that, it's in the tens, something 9. And then 7 to the third, well, we don't really care about that, but 9 times 7 is 63, so it's going to end in a 3. And then 7 to the fourth, well, 3 times 7 is something 21. And then, conveniently, then 7 to the fifth, well, it's just whatever that value is at the very end multiplied by 1, which is going to be itself, so we're going to have 7 again. So there's actually a pattern here, and that's really the trick to this question, is recognizing that the units digit of 7 actually conforms to a pattern. So it's also a 4-term pattern, so very nice. We just take 236. Now that we know the number of terms in a pattern, we divide by 4. That's going to be 5. There's 20. Take away 20, we're left with 3, 36. And 4 into 36 is 9. So we have remainder nothing, which means it's the very last term, which is 1. Okay, looking at our second problem. All right, we have I to the power of 1,236. So I'm really trying to hammer home this issue of it not mattering. And plus I to the power of 622. So we can just go ahead and divide both of those by 4. It's nice that they're even. So 1,236 divided by 4, that's 3, 12, so much math. Why did I do this to myself? 0, 3, that's nothing fits in there, and 36 is next, and that's a 9 again, so 309. And so that's no remainder again, and so actually let's very quickly write our pattern of I. So that goes I, -1, -I, and then 1. So I to the power of 1,236 is 1. And then let's do 622. So 622 divided by 4, there's 1 there. And 22, that's going to be 5. And we got 20 and 2 left, 155. And then what we have here is 2 left over, so remainder 2. And so our second term in the pattern is -1. So that's going to be 1 plus -1, and that is 0. So very nice. And what you can see there is these big intimidating exponents, when we're doing pattern math, can just drop out, and we're back down to, 1 plus -1. That's pretty okay. If you were telling me that all I had to do is answer what is 1 plus -1 for me to get to college, I would be pretty comfortable with that. Okay, that's it for this video. There's some really interesting and fun pattern math problems out there, and so hopefully I've been able to show you how to spot and solve them, because if you do them the wrong way, they take forever. you do it the right way, it's pretty okay. If you found this material useful, we hope that you will like and share the video and subscribe to Quad Education. If you have any needs for tutoring, please reach out to us and we're happy to help. Thank you for watching, and I hope you have a great day.